Okay, so this video is going to be about how you can find the enthalpy change of a reaction using provided enthalpies of formation. Enthalpies of formation, the definition of the enthalpy of formation is the energy change when 1 mole of a substance is formed from its elements in their standard states. You do need to know this definition. And as with all standard energy changes, these must happen under standard conditions. So 298 Kelvin and 100 kilopascals. So in order to explain how we can use the enthalpy changes of formation to determine the enthalpy change of reaction, I'm going to use as an example the combustion of methane. So CH4 reacts with oxygen to form carbon dioxide and water. Now, if you're given this equation, the first thing you need to do is you need to find the enthalpy changes of formation of each of the substances in this equation. So in your data booklet, you'll be able to find the enthalpy changes of formation of methane, carbon dioxide and water. Note that oxygen is already an element, and therefore if you look at the definition, if you're forming an element from an element, there will be no energy change associated with that. So you don't need to find enthalpy changes of formation values for substances that are already elements in the stated equation. So the enthalpy change of formation of methane, the equation for this is going to be, since we're forming methane, the enthalpy change of formation of methane is going to be formed from carbon as a solid and hydrogen as a gas, and it's going to be forming methane as a gas. And the value for the enthalpy change of formation of methane is minus 74 kilojoules per mole. The enthalpy change of formation of carbon dioxide, and we're forming 1 mole of each of these substances. It's formed from carbon as a solid and oxygen as a gas, and it's forming carbon dioxide gas, and the enthalpy change of formation of carbon dioxide is minus 393.5 kilojoules per mole. And the enthalpy change of formation of water, and water is a liquid in its standard state, is formed from hydrogen as a gas and oxygen as a gas, but notice we must only form 1 mole of water, so we have to have half a mole of oxygen in order to form that, and the enthalpy change there is minus 285.8 kilojoules per mole. And so these values you can find from your data book. So now we have the equations for the formation of each of these substances in the reaction that we are given. So there are 2 alternative methods that you can use to determine the overall enthalpy change of this reaction. The first is to simply form a cycle, an energy cycle, using these equations. So since methane is in our original equation, and carbon dioxide is in our original equation, and water is in our original equation, then the substances here on the left-hand side, the elements that we are using to form these compounds, these are going to have to form the third point of our energy cycle. So methane can be formed from carbon and hydrogen. Carbon dioxide can be formed from carbon and oxygen. The carbon is already there. And water can be formed from hydrogen and oxygen. We have to have another oxygen molecule here. And now we have enough carbon to form the methane, enough hydrogen to form the methane, and also enough carbon to form the carbon dioxide, and enough oxygen and enough hydrogen and oxygen to form the water. And the oxygens here, there is no 4th arrow for the oxygens because there is no enthalpy change associated with the formation of oxygen. So the energies associated with each of these arrows as they are written is minus 74 kilojoules per mole for the methane, minus 393.5 kilojoules per mole for the carbon dioxide, and 2 times minus 285.8 kilojoules per mole for the water, since we are forming 2 moles of water here in this equation rather than just 1 mole, which is what we are provided with in the equation here. So overall, the enthalpy change for this reaction that we are given, this enthalpy here for the formation of methane, the arrow is pointing the wrong direction for our energy cycle. So in the energy cycle, the arrows must follow the original arrow. So this arrow is going to have to reverse direction. So we're going to have positive 74 as we're going the other way. And then we can simply add on minus 393.5 for the carbon dioxide and 2 times minus 285.8 for the water to give us our overall enthalpy change for the reaction, which is minus 891.1 kilojoules per mole for the combustion of methane. So that's the first method that we can use. The second method we can use to do the same thing is, rather than writing it as an energy cycle, we can simply consider each reaction separately in order to get from our reagents to our products. So, the enthalpy of formation of methane involves carbon and hydrogen reacting to form methane. Well, here we're starting with methane, and we're going to reverse the direction of this reaction, so we're going to form carbon and hydrogen. And that is obviously going to have an energy change of positive 74 kilojoules per mole, since we've reversed the direction of the arrow here. For the oxygen, we can ignore that for the moment, but then we have carbon plus oxygen forming carbon dioxide. And again, this is exactly as written there, so we don't need to change the sign, so 393.5 kilojoules per mole for the formation of carbon dioxide. And then we have oxygen plus hydrogen, and we have 2 of them, forming our 2 water molecules, and that is going to have an energy change associated of 2 times minus 285.8 kilojoules per mole. So now we have the energy, the reverse energy for the formation of methane, since we are breaking our methane down, the energy of formation of carbon dioxide, the energy of formation of 2 water molecules. We can now add together these values here, and again the result is minus 891.1 kilojoules per mole, which is the enthalpy change of our overall process to go from this side to this side.